Hello everyone and welcome back. Today we will do 3 examples related to the properties of the determinant. Okay, the example 6.3.2 says if the determinant of A, which has the size 3 by 3, equals 5, and the determinant of B, which is again the size 3 by 3, equals -2, then evaluate this determinant right here. Good. So we should evaluate this determinant. Okay, the first common mistakes sometimes happens is people pull out the 2 from the determinant, which is wrong. The reason is 2a, the whole matrix 2a is under the inverse. So it means that the inverse should be applied to 2a, not just a. Okay? And also you have 5b transpose. Well, the first property we use is we distribute determinant to this matrix and to the other one using the property right here we had last time. Now, the first determinant, because it's 2a, the whole thing inverse, equals 1 over determinant of 2a. And determinant of 5b transpose will be determinant of just 5b. And then this equals the determinant of, let me rewrite that, 5b over the determinant of 2a. Now we want to pull out 5, okay? So we pull out 5, and also we pull out 2. However, is this correct? The answer is no. We have to raise 5 to the size of the determinant, because we have here, right here, we have a 3 by 3, because of that 3 here. So that 3 right here. Good. And then this becomes 5 cubed. The determinant of B is -2. And then 2 cubed. The determinant of A is 5. And then if you simplify, you get 25 minus over 4. Good. Example 6.3.3. If A is 4 by 4 and A cubed minus 3A is 0, find the values of determinant of A. Well, first of all, a common mistake that sometimes happens, people write determinant of A cubed minus 3A equals the determinant of A cubed. Oopsies. There's no space there. Not a good idea. Okay, so be careful that the determinant of A cubed minus 3A is not equal to necessarily to the determinant of A cubed plus determinant of minus 3A, or minus determinant of 3A anyways. Okay, so what should I do? Well, first you move 3A to the other side. Then you apply the determinant to both sides. Then determinant of A cubed. A cubed is A times A times A. And you can apply determinant to each. So determinant of A times, determinant of A times, determinant of A. But that is just determinant of A, the whole thing cubed. And then pull out 3, but you have to raise it to power 4 because of this 4 by 4 right here. Okay. Now we have to solve an equation whose unknown is determinant of A. You can call determinant of A and you can replace it by X and continue. but you don't have to. Well, so we get, now, because determinant of A is indeed a numerical value, it's just a scalar. Now factor out, be careful. You shouldn't cross determinant of A right here from both sides. That's a common mistake people do in solving equations. Now you factor out determinant of A, you get determinant of A, the whole thing squared minus 81 equals 0. Then we have either determinant of A 0, so we found one of the possibilities of the solution. Or you just write determinant of A squared equals 81. That's why determinant of A is 9, or determinant of A is minus 9. So these are 3 answers for the determinant. I would like to ask a question. In this question, can I say A is invertible? The answer is no, because the determinant can be 0 or not 0. So in general, the answer is no. Okay, let's move to example 6.3.3. Let A be a 3 by 3 matrix with entries 8, 3, 1, 2, 1, x, 6, 3, 1. For which values of x is the matrix A invertible? So we want to use a theorem. We say A is invertible if and only if determinant of A is not 0. So A is invertible if and only if determinant of A is not 0. So we should calculate the determinant of A. Well, let's evaluate the determinant of A. You have different ways to do that. You can copy the first 2 columns and keep going. I do cofactor expansion along the first row. It doesn't matter. So we get 8 times 1 minus 3x minus 3 times, because plus minus plus, 2 minus 6x plus 6 minus 6. That becomes 8. Let me simplify. 8 minus 24x minus 6 plus 18x. That gives us minus 6x plus 2. Good. So you see, it says for which values of x is the matrix A invertible. So the determinant should not be 0. And that implies x should not be 1 over 3. So that's the answer. So x can be any number except 1/3. Good. It's enough for today. Next time we will talk about Kramer's rule. Enjoy the rest of your day. Bye.